Next kind of problem we're going to see is the initial value problem. For an initial value problem, these are relying on the relationship that exists between derivatives and antiderivatives. So for example, if I were to give you f and ask you to come up with f prime or f double prime, in both of these cases you would be taking derivatives. Whereas if you were to start with f double prime and start working your way backwards, in this direction you would be doing antiderivatives. Now, the idea behind an initial value problem is that you will be given either a first or a second or a third or a fourth or a fifth derivative, and you'll be asked to find what is the original function f that gets you there. However, every time you do an antiderivative, it'll be necessary to add in an additional constant, that plus c that we've talked about. As a result, you will need initial conditions to solve for that plus c. An initial condition would be the value of a function at a given x value, allowing you to solve for a plus c. An example of a very straightforward initial value problem would be something like f prime of x is equal to 3x squared and f of 0 is equal to 6. So here is where we're going to be performing our antiderivative to take us from a derivative back to the original function, and this would be considered an initial condition. Hi, baby. Now, we've already talked about what the antiderivative of this would look like. The antiderivative of a derivative is going to be whatever that antiderivative is plus your generic c. Now, this is where you can plug in your initial condition. The interpretation of the initial condition is plug in x equals 0 and f of x will be equal to 6, giving us that 6 is equal to 0 cubed plus c, allowing you to solve for c. In this case, that would be c is equal to 6. So the original function f that we were looking for from right here, f of x, would be equal to x cubed plus 6. In the next video, we'll do a couple more elaborate examples.